example. Let me bring the picture for the example. Be somewhere there. There you go. It's pretty messy. A bunch of forces and different directions are applying to this plate. Happens a lot when you're later on, I guess next year, you'll take machine design and you will see this happens a lot. You have so many forces, you want to design a specific part. The first step you need to do is to simplify the system and figure out what are the moments about the specific point, or generally moments applied to this part in your machine, before you take it one step further and figure out, how to design it to handle that much moment under those forces. So you can go with this problem statement that determine the resultant force, resultant of the moments, sorry, we're talking about moments created by the forces on the plate. Could be any type of plate, looks like it might be a concrete plate somewhere supporting some structure. So, first question, how many couples do you see in this problem here? Can you identify the number of couples? Sets of couples. Let's put it this way. 3, 3, 3, 3, good. Everybody found a couple. So we have 3 couples. Right? Hopefully you all identified that. It's this one, well, let's just start with F1, right? This one and this one. Maybe I should use a better color. So these 2 create a couple. These 2 create a couple. And then these 2 also create a couple, because these are forces with the same magnitude and they are acting in opposite directions. So let's just start with, let me just emphasize, we have 3, I don't know why my handwriting is so bad. We have 3 sets of couples. So the resultant moment, right? And I follow the notation in 3-dimensional space. I'm going to take counterclockwise as positive. This I'll take as positive. Is the summation of all the moments, right, I1 to 3, meaning that it's going to be M1 plus M2 plus M3. Let's find each of them. Let's find M1. So I'll start with the magnitude. Actually, we can, let's see how do we do it. I'm going to put those 2 forces separately here so things are not missed. So this is, let's say this is my, this way, and then I have the other force in this way. Let's say this is F1 and this is F1, obviously, and this is the distance D1. Now, can someone tell me what is the value for M1? Magnitude. So we have D1 times F1. We have D1 and we have F1. So pretty straightforward. Exactly, 800. So that would be F1 D1. So it would be 200 times 4, which would be 800. The unit, pound foot. Now, how about the direction? Is it positive or negative? Negative, exactly. So follow the right hand rule, right? Four fingers, one of the forces, doesn't matter which one, as long as the palm of your hand is facing the middle point or the other force, and make a fist. So in this case, it's clockwise, right? The moment is in this direction, which is negative because I took counterclockwise as positive. So this is negative, and this is negative. Going to M2, that moment. Now we have F2. Let me draw the forces here again so everyone can follow what we're doing. Am I gonna make it messy? Let me make it, draw it a little lower, somewhere here. M2. Draw the forces. This is F2, one of them, and the other one is in this direction. So that becomes F2, F2, and this is the distance, D2. Now looking at that figure, we have D2, right, the distance. We have F2. So we can just easily put it here. So now the question is it positive or negative? Positive, positive, positive. Good. I'm positive that is positive. So F2, D2, remember right hand rule, direction of the force, one of them, the palm is facing the other force or the point between two forces, trying to make a fist, four fingers show the direction. So this is the direction. Now I took this direction, which is counterclockwise, as positive, which means this is positive. So F2, D2, F2 is 450 times D2, which is 3. Whatever the value is. I actually don't know. I'm going to do it quickly. 450 times 3 is 1350. Oh, thank you, Michael. 1350 pound foot. Third one, M3. Let's draw the forces here. Take them out of that figure. This is one of the forces. This is the other one. And here is the distance between these two. D3. This is F3 and this is F3. So M3, well, would be F3, D3. F3, I have 300 pounds, and D3 is 5 feet. So 300 times 5. Now, positive or negative? Force is this way. Make a fist, becomes clockwise, meaning that we have negative, because we took counterclockwise as positive, as a standard. So this becomes negative. Negative 1500 pound foot. So pretty straightforward now, right? We have MR there. Now we already found M1, M2, and M3. So the MR value, or this vector, let's put it this way, comes minus 800 plus 1350 minus, did I do it correctly? Minus 800 plus 1350 minus 1500. Yeah, this is minus 1500. Should give you the value. And this becomes pound foot. So counterclockwise is positive. Yes, always in this course, when we're in two-dimensional space, always counterclockwise is positive. And you can think about it, if you want to make sense out of it, you can think about the unit circle for angles. Right? When you have the unit circle, you're looking at angles, 30 degrees, 40 degrees, 90 degrees. We move counterclockwise, and that's why counterclockwise is positive for us. So this gives you the pound force, the value, and depending on, it should be negative. So let me do the math. 500, 1523. It should give you 950, I think. Should the right hand rule the first and one? Sure. So this becomes minus value, or you can just look at it as MR with 950 pound force, a pound foot, and show the direction using some arrow instead of writing it in positive and negative. You can just write it this way.